bidirection unit. 8207 drum controller. 8210 TTL to MOS shifter and high voltage clock driver. 8212 8-bit I/O port. The industrial version of ID 8212 was available for $6.75 in quantities of 100.13. 8216 4-bit parallel bidirectional bus driver. The industrial version of ID 8216 was available for $6.40 in quantities of 100.13. 8218 /8219 bus controller. 8226 4-bit parallel bidirectional bus driver. The industrial version of ID 8226 was available for $6.40 in quantities of 100.13. 8231 arithmetic processing unit. 8232 floating point processor. 8237 DMA controller. 8251 communication controller. 8253 programmable interval timer. 8254 programmable interval timer. The 82C54 CMOS version was outsourced to Oki Electronic Industry Company, Limited, 23. 8255 programmable peripheral interface. 8256 multifunction peripheral. This chip combines Intel 8251 a programmable communications interface, Intel 8253 programmable interval timer, Intel 8255 a programmable peripheral interface and Intel 8259 a programmable interrupt controller. This multifunction chip uses serial communications, parallel I/O, counter/timers and interrupts. The Intel 8256R was available for $21.40 in quantities of 100.24. 8257 DMA controller. 8259 programmable interrupt controller. 8271 programmable floppy disk controller. 8272 single /double density floppy disk controller. It is compatible with IBM 3740 and System 34 formats and provides both frequency modulation, FM, or modified frequency modulation, MFM. This version was available for $38.10 in quantities of 100.25. 8273 programmable HDLC/SDLC protocol controller. This device supports ISO/XITS HDLC and UBMS SDLC communication protocols. These were available for $33.75, 4 MHz, and $30.00, 8 MHz, in quantities of 100.25. 8274 multi-protocol serial controller. This support 3 different protocols using the following feature of asynchronous operation, byte synchronous operation and bit synchronous operation. The byte synchronous mode is compatible to IBM's BiSync signal protocol. The bit synchronous mode is compatible to IBM's SDLC and the International Standards Organization's HDLC protocol and is compatible with XIT X.25 international standard as well. It was packaged in 40-pin product using Intel's MOS technology. The available version is rated up to 880 kilobaud for $30.30 in the quantities of 100.26. NEC PD7201 was also compatible. 8275 programmable CRT controller. It refreshes the raster scan display by buffering from main memory and keeping track of the display portion. This version was available for $32.00 in quantities of 100.25. 8276 small system CRT controller. 8278 programmable keyboard interface. 8279 keyboard / display controller. 8282 8-bit non-inverting latch with output buffer. 8283 8-bit inverting latch with output buffer. 8291 BIP talker / listener. This controller can operate from 1 to 8 MHz. It was available for $23.75 in quantities of 100.25. 8292 BIP controller. Designed around Intel 8041, of which it has been programmed as an controller interface element. It also controls the bus using 3 lockup timers to detect issues on the BIS interface. It was available for $21.25 in quantities of 100.25. 8293 BIP transceiver. This chipset supports up to 4 different modes. Mode 0 talker / listener control lines. Mode 1 talker / listener / controller control lines. Mode 2 talker / listener / controller data lines. And Mode 3 talker / listener data lines. It was available for $11.50 in quantities of 100. At the time of release, it was available in samples, then full production in the first quarter of 1980. 8294 data encryption / decryption unit +10 /P port. It encrypts and decrypts 64-bit blocks of data using the Federal Information Processing Data Encryption Standard algorithm. This also uses the National Bureau of Standards encryption algorithm. This DO operates using a 56-bit user-specified key to generate 64-bit cipher words. It was available for $22.50 in quantities of 100.25. 8295. Matrix printer controller. This interfaces with LRC 7040 series. Matrix printers and other small printers as well. It was available for $20.65 in quantities of 100.25. Educational use. In many engineering schools, the 8085 processor is used in introductory microprocessor courses. Trainer kits composed of a printed circuit board, 8085, and supporting hardware are offered by various companies. These kits usually include complete documentation allowing a student to go from soldering to assembly language programming in a single course. Also, the architecture and instruction set of the 8085 are easy for a student to understand. Shared project versions of educational and hobby 8085 based single-board computers are noted below in the external links section of this article. Simulators. Software simulators are available for the 8085 microprocessor, which allow simulated execution of opcodes in a graphical environment. See also. IBM System / 23 Datamaster gave IBM designers familiarity with the 8085 support chips used in the IBM. Notes. One note that the Z80 assigns different instructions to of the Z80S6 relative jumps to the opcodes that 8085 uses for RIM and SIM, making 8085 programs that use these instructions generally unable to run on the Z80 without modification. Since use of these instructions usually relates to 8085 specific hardware features, the necessary program modification would typically be non-trivial. Even so, there is no need for 7 different effectively identical delay instructions, and they are also identical in effect and form to the NOP instruction, except that NOP conveniently has the opcode 00 hex. 3. The trap interrupt, being an NMI, can always bring the 8085 out of the hold state. References. 1. CPU history. The CPU.
So that was half an hour and the power is red, so actually did finish. That was the Intel 8085. That was 8-bit CPU. So next one is the modern 16-bit, this X86 family. But I think before we do that, we need to know what 4-bit is. What is 4-bit CPUs? What is 8-bit CPUs? But we need to know this Fagi, who's make this. He made this. We need to have about him. Called Federico Fagins. That's the one here. Federico Fagins. He was designer of this this Intel 4004 chip. So we need to know about him. But before that, we need to know what is 4 bits. What is 4 bits? I think we should do that next time. What is 4 bit and what is 8 bits? What is 4-bit computing and what is 8-bit computing? We need to know that. But I think before we do that, we play the Federico Fagins. So let's put that to 0. Then we do the 4-bit, then the 8-bit, and then what a DIP is and what is a DIP 40. So, yes, that was the Intel 8085. But let's just close that. And next one is Federico Fagins, because he's the father of the 4004, the first 4-bit Intel CPU using this Japanese calculator called BUSI 141. That's the calculator we need. No, that's the BUSI something. But I'm not going to open too much because this computer crash, it go to black screen because this is super hot. This is super hot. This is burning hot there. So suddenly the screen gets black, or the computer is freezing. But now it's 6 p.m. and 6:30 we have the news in Danish, so we have to charge this camcorder like 2 hours. Then we can do some more. But that's fine. I did finish record this. So, but I was watching the first part of the video about the Intel 186, and I think this will work well. We're reading this text, and this the letters is pretty big, so you can read it on the video. So I think that could be helpful for some. That's helpful for me. I just go to there, and I will stop the video. But I will record later. Just need power. If I had a lot of power on the camcorder, I will just continue. But it takes 5 hours to charge. But we cannot wait 5 hours because then it's like 11 or midnight. We cannot do that. So just give it like 1.5 hours, 1 hour power.